Today we're going to take a look at the topic 3 review. This is on page 187 of your textbook. So I'll start off with just kind of this vocabulary review at the top. We're not going to go through this, but it's a really good idea to make sure you understand the definitions and the vocab that are in this unit. I think I just got off of a Zoom call with a student from geometry, and because they weren't sure what the vocab words meant or the definitions, or maybe another way to write something like how to translate something, something that a symbol that they use to represent that, they weren't sure what they were supposed to be doing. So it's not enough to just kind of be able to superficially, read the problem and work through it. Make sure you understand the vocabulary words in the lesson, because they might use that to just prompt you to answer a question. If you don't know what the vocab word means, then you're, out of luck. So again, I'm not going to go through this, but you're more than welcome to access that answers and solutions manual that I post every week. So in this week's review, in this week's section, you'll see a solutions manual there, and then you can look in that for the correct vocab words, which ones go with the correct problems. So we will start off with lesson 3.1. Graphing polynomial functions. So again, you could see that it kind of highlights some critical vocab when it goes through here. So make sure you know what a polynomial means. Make sure you know what a term is, things like that. So this quick review is a good paragraph to read to make sure you kind of understand what's happening and what it's, the lesson summarized is all about. Again, this isn't like the entirety of the lesson. Not every single piece of the lesson is there, but just a quick summary of it is there. So they want you to graph this function f of x equals 2x cubed minus x squared minus 13x minus 6. They are giving you that there's zeros there. So essentially what I would recommend you do, if we were in a classroom, it'd be something different probably. I'd probably, prompt you to do this a different way. But because we're in the environment we're in, and because computers and calculators are so prevalent in the world, I would always encourage you to use a computer or a calculator if you have one. So definitely if you have a calculator, a graphing calculator, you're more than welcome to graph this problem, that function, and it'll give you that picture. And then just by looking at the picture, you can tell that my x-intercepts are at -2, probably about -1/2. Again, you'd have to trace that out on your calculator to find out if it's exactly -1/2 and +3. If you don't have a graphing calculators, no worries, because you have something called Desmos. Let me go ahead and write that down just in case somebody hasn't accessed that yet. So Desmos, this is an online graphing calculator, lots of other tools that are embedded in that program or in that website. But if you just Google Desmos graphing calculator, you'll be able to click on that and then just type that function in there, and it'll give you this picture of that function. Also in Desmos, the cool thing is you can just click on those x-intercepts and it'll tell you exactly where they are, what the values are. You can click on the maximum and minimums. You can do a lot of things in Desmos. So I would encourage you to go and play around with that and make sure you can use that effectively. So just to go through here, what they're talking about, there are zeros at -2, -1/2, and +3. We just kind of addressed that a second ago. There are turning points. Sometimes you call these maximum because it's a maximum height that reaches a maximum height there. And they call these minimums because they reach a minimum height down here. It comes down, 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 and then it stops and turns around and goes back up. So that's a minimum value. They're calling these turning points. So make sure, again, in math, you can go to 3 different websites and see the same thing called 3 different things. They have a lot of vocab words or terminology for the same things. Just like x-intercepts, right? We call these roots, we call these zeros, we call them x-intercepts. It just kind of depends on where you're at. So just be aware that these are called turning points, where the function is turning and going back the other direction. So there are turning points between -2 and -0.5. They determine that because that's my x-intercepts. So between those 2 x-intercepts, there's a turning point. And then between -0.5 and 3, again, my other 2 x-intercepts, there's another turning point. So it comes down, turns around, and comes back up. And then this is that end behavior portion of it. So as x approaches negative infinity, make sure you understand how to read this. As x approaches negative infinity, which means as we trace this function to the left, right? That way, that's negative infinity to the left. So as we trace it to the left, my function goes down to negative infinity. What about the other direction? As x approaches positive infinity, so positive infinity is to the right. So as we trace our function to the right, it looks like our function goes up towards positive infinity. So end behavior. Practice and problem solving, graph the polynomial function, estimate the zeros and the turning points of each graph. So I think we will go ahead and practice that with Desmos. So I'm going to go over to Desmos and type that function in. There's my Desmos. This is something from before. So let's go ahead and type that function in. So number 9, x to the 5th plus 2x to the 4th. So x to the 5th plus 2x to the 4th minus 10x cubed minus 20x squared minus 10x cubed minus 20x squared plus 9x plus 18. All right, so we're over at Desmos. You can see this is a super nasty function, right? I mean, let me zoom out just a little bit so you can get an overall picture of this. Overall, this is an odd positive function. So you know that it's going to start down here in the bottom right, and then it's going to come up and do some wiggles. It'll do some stuff, but then it'll shoot off to the top right. So an odd positive function always has that end behavior. Let's zoom in because I think what we want to do is, what are they saying? Graph these polynomial functions, estimate the zeros and the turning points. So look at my zeros. You could see that they're already kind of grayed out once you hover over them. I didn't have to click on it. Once you hover, you could see that your zero, your x-intercept, is at -3, -2, -1, 1, and 3. So I've got 5 x-intercepts here. Then they want your turning points. So again, how they do this is they focus on, if you trace this function up from where it starts, it crosses my x-axis, it comes up, it does a turn. We don't really care how far it comes up or where it turns, but it comes back down and then it crosses the x-axis again. So when they want your turning points, they're basically saying identify between the two x-intercepts. So what I would say here is between -3 and -2, there's a turning point. Between -2 and -1, there's a turning point. Between -1 and 1, there's a turning point way up there. Between 1 and 3, there's a turning point way down there. And then that's it. There's just 4 of those turning points. Number 10 is x to the 4th plus x cubed. So I'm just going to go ahead and change this around. X to the 4th plus x cubed minus 16x squared minus 4x plus 48. All right, minus 4x plus 48. There we go. Again, overall, we know that this is an even degree function because that's the highest degree I have. And it's positive because that's positive x to the 4th. So it's a positive even function. So if you zoom out, you know it should start up here on the top left. We can zoom out a little bit further, but the picture kind of, there we go. Starts up here on the top left. It comes down, does some wiggles, does some stuff, but then eventually it's going to turn around and go back up to the top right. So every positive even function does that. So they're looking for your x-intercepts, -4, -2, 2, and 3. And then along with the x-intercepts, or what they're calling zeros, they want your turning points, the maximum and minimums. So the first turning point looks like it's way down here, and it's between the x-intercepts -4 and -2. The next turning point is way up there. Looks like it's between the x-intercepts -2 and 2. All the way up there is the turning point. And then the last one, which we can actually see on our screen right here, the last turning point's between 2 and 3. There's a turning point right there. All right, go ahead and stop sharing, head back over to my book. Okay, so numbers 9 and 10 taken care of. Number 11, reason a polynomial function has the following end behavior as x approaches -infinity. So what they're saying here is if you have a graph, let's see if I can get this all on the same thing. So here is my axes. That's my y-axis, that's my x. Remember, if you go left, that's the negative direction. If you go right, that's the positive direction. If I go up, that's the positive direction. If I go down, that's the negative direction. So they're saying here as x approaches -infinity, so as I go to the left, what is my function going to do? My function is going to go to positive infinity. So as I go to the left, my function is going to go up. I don't know what's happening yet, but that's just all the information they gave me. And then as x goes to positive infinity, so as I go to the right, so I come down and I do whatever, I don't know what I'm doing, but I'm heading to the right, my function is going down to -infinity. So after I come down and I do some stuff, it's going to end up going down to -infinity. Describe the degree and leading coefficient of the polynomial function. Again, there was 4 different situations. There was a positive even, a positive odd, a negative even, and a negative odd. So if you don't remember what those were, go back in the lesson and look those up. Positive even functions always have the same behavior. Positive odd functions always have the same behavior. In this case, this looks like it's going to be a negative odd function. So every negative odd function is always going to start off in the top left and go down to the bottom right. So an example would be something like -3x cubed plus 7x plus 5, -9x to the 9th plus 8x to the 8th minus 4x squared plus 3, right? Whoops, sorry, I'm off my page. Those are both examples of odd negative functions. So the odd degree deals with the leading degree, the highest degree in that function. Those are odd numbers. And then the leading coefficient is negative. That's where they get those names, odd negative functions. So every odd negative function looks like that. So describe the degree and leading coefficient of the polynomial function. That would be the answer. It would be an odd negative function. Number 12, make sense and persevere. After X hours of hiking, Sadie's elevation is P of X in meters. After how many hours will Sadie's elevation be 18 meters below sea level? What do the X and Y intercepts of the graph mean in this context? So what I think I'm going to do with this problem is, again, just like I encouraged you at the beginning, this is talking about graphing this function. So I'm going to go and graph this in Desmos and see what I get. So let's head over there. So I've got negative x cubed plus 11x squared minus 34x plus 24 already typed in there. If we can kind of zoom in on this a little bit, you can see what those x-intercepts are. So here's the function that represents, let me get this right, after X hours of hiking, this function represents Sadie's elevation. So after 1 hour of hiking, 2 hours of hiking, 3 hours of hiking, right? So as time goes by, this graph represents Sadie's elevation. These x-intercepts that they were asking about, 1, 4, and 6, basically represent at hour 1, right? I am 0 feet, or what are they talking about here? Meters. I am 0 meters off of the ground. So it's an x-intercept. So basically they're at sea level. And then they drop below sea level, go down to a minimum, jump back up, and then back after 4 hours, she's back at sea level. And then after another couple of hours, she's back down to sea level, and then she drops down below it. So let me see what questions they're asking here. After how many hours will Sadie's elevation be 18 meters below sea level? So below sea level basically means negative 18 on your y-axis, which is right here. Let's see if we can get this exactly on here. There we go. Oh man, now I lost it. There we are. So right now I'm clicking and holding on this function. So as I click and hold on it, I can trace and drag that function to get the value I want. And since they want negative 18 meters, there we go. X represents the hours. So after 7 hours, Sadie is negative 18 meters below water, below the surface of the water, right? So that's how you'd find that. And then the last one, what do the X and Y intercepts of the graph mean? We already talked about the X intercepts, basically saying that's each time she reaches, sea level. So they start off above sea level, hit sea level, drop below it, hit sea level, go above it, hit sea level, drop below it. But we didn't talk about the y-intercept. So let's take a look if we can find it. There we go. What the y-intercept is basically saying, remember the function says that x represents time, y represents meters, that Sadie is her elevation. So what this y-intercept represents is at 0 minutes, right? So where Sadie is starting to hike, she is 24 meters above. She's 24 meters above sea level. That's her elevation. All right, so let's go back over here. And that is lesson 3.1. Take a look at lesson 3.2. So this lesson or this review, I don't know why they do this sometimes. Again, this is the first year we've ever used this book, so it's kind of interesting to go through it and see how they're formatting it and what they're including and what they're not including. This review basically lumps 3.2 and 3.3 into the same review. So we'll kind of kick out the 3.3 stuff. That's the one we skipped, which is polynomial identities. Not really a super difficult concept to understand. It's almost like dealing with formulas. We'll kind of hit on it right here, but you're not going to have any test questions about that. So a quick review: to add or subtract polynomials, add or subtract like terms. To multiply polynomials, use the distributive property. So what they're saying there is if you want to add or subtract polynomials, you have to add or subtract x squareds to other x squareds. X cubes can only add or subtract to other x cubes. I wish I had an example here, but I don't. We might see one later on. But if I had an x here, like this 2x here, if I had no other x's over here, it couldn't add to anything else. X cubes add to x cubes, x squareds add to x squareds, and nothing else. But when it comes to multiplying polynomials, it's game on. You can multiply negative 2x cubed times x. You can multiply 2x times x cubed. Multiplication, there are no real rules. Everything multiplies by everything. And then polynomial identities, again, an easy way to think about this is it's almost like formulas that you're plugging things into, you're plugging information into to factor out things. But we skipped that, so we're going to skip that on here. So here's an example. Like I was talking about, I can only add this x cubed to another x cubed, right? So negative 2x cubed plus x cubed. Negative 2 plus 1 is essentially what's happening here. That's negative 1x cubed. Bam. It looks like they are, when they're working through their problems here, they start off with the original equation and then they group like terms, which is kind of nice. So then they have x squareds over here. They've got an x squared over here. So they took those two terms and they grouped them together. That's what their work is showing. So 5x squared minus 6x squared, that's essentially the same thing as saying 5 minus 6. That's negative 1x squared. Then 2x and x, so they group those together. If I have 2 x's and I add an x, that means I have 3 x's. And then negative 3 plus 12, that's just like adding constants together. So negative 3 plus 12 is 9. So that would be my final answer. I couldn't add any of these terms together because they're not like terms. They have to have the same degree, right? The same power, and they have to have the same variable. So sure, they all have the same variable, but they don't have the same power. This polynomial identity is kind of like I was saying earlier. It's almost like plugging things into a formula. So you can see that stressed with this first step right here. You can take any function that looks something like a cubed plus b cubed, and you can rewrite it as a plus b times a squared minus ab plus b squared. So it's almost like a formula. It's a bit confusing because they don't always give it to you in this form. You have to kind of manipulate it sometimes, which is the reason why we skipped that. So if you do want to see anything like that, feel free to email me. I'm happy to work through some of those problems with you. So the first one, number 13, add or subtract these polynomials. So let's go ahead and get these written down. Negative 8x cubed, I know I can only add that to other x cubes, and it looks like I do have one. I've got a 5x cubed there. So negative 8x cubed plus 5x cubed. I'm just kind of grouping them, kind of like they did in that workbook a second ago. 7x squared plus 3x squared. X plus negative 2x. And then negative 9 plus negative 1. Some people don't like to write plus negative 1. They would have just wrote negative 9 minus 1. That's totally fine too. So here, if you wrote x minus 2x, that's perfect. So now I will add these like terms. Negative 8x cubed plus 5x cubed is negative 3x cubed. 7x squared plus 3x squared is 10x squared. X plus negative 2x, or x minus 2x, that's negative x. And then negative 9 plus negative 1, that's negative 10. Again, you could have written this as like this, plus 10x squared plus negative x plus negative 10. You're not going to really see that, these kind of double signs like that. Anywhere throughout the book, anytime I talk about something, I'll always simplify that. Instead of writing plus negative, I'll just write it as minus. It's just kind of less stuff to worry about. So number 14, same kind of thing. 9y to the fourth minus 2y to the fourth. So 9y to the fourth minus 2y to the fourth is 7y to the fourth. Negative y cubed minus negative 3y cubed. So be careful here. Negative y cubed minus negative 3y cubed. That's going to be 2y cubed. Remember, when I subtract a negative, that's the same thing as adding that thing. So technically, this is the same as negative y cubed plus 3y cubed. 4y squared minus, there is no y squared over here. So it's just going to be 4y squared as part of my problem, or part of my solution. Y minus 6y, that's negative 5y. And then negative 2 minus negative 7 is positive 5. So that would be my simplified polynomial. Now they want us to multiply. How I would recommend this is multiply the first two sets of parentheses together first. And then once I get that product, I'm going to go ahead and multiply it by that third set of parentheses. So 9x minus 1, x plus 5, x 7x plus 2. Okay. So what I'm going to do is I'm going to ignore that third set of parentheses, and I'm going to multiply those first two together first. I like the FOIL method. You could use the box method, whatever you want to use to multiply those out. It's up to you. Some people like to draw that box and then write 9x minus 1 across the top, x plus 5 down the side, and then multiply each row in each column. So 9x times 5 is 45x. Negative 1 times 5 is negative 5. They like to do that. I'm going to do FOIL, which is just first times first, outside times outside, inside times inside, last times last. So what I would get would be negative 9x squared. 9x times 5 is 45x. Negative 1 times x is negative x. Negative 1 times 5 is negative 5. And if I simplify that, I add my like terms. 45x minus x is 44x. And this is where I'll bring down that last set of parentheses and multiply them out. So now I've got a binomial times a trinomial. So very similar to, FOIL method. What I'm going to do is basically something they call double distribution. I'm going to distribute the 7x to all three terms, and then I'll distribute the 2 to all three terms, and then add my like terms that I'm left with. So 7x times 9x squared, that's going to be 63x cubed. 7x times 44, oh my gosh. 280, 308 plus 308x squared. I'm going to double check that because I don't want to screw something up. 44 times 7. 308. And then negative 5 times 7x, that's negative 35x. And then I'll move out to the 2. So 2 times 9x squared is 18x squared. 2 times 44x is 88x. 2 times negative 5 is negative 10. When you multiply this all out, you don't have to stack these like I did. So I stack my x cubes on top of each other. I stack my x squareds on top of each other. I stack my x's. You could have written this as one long line and then just combine like terms, but this is just a way that I can visually stack my like terms and add them up. So there are no other x cubes. If I add my x squareds, that's 326. If I add my x's, what do you think? 53, 53x. And then my constants all by itself, I'm not adding or subtracting anything to that. So that would be my final answer. So number 16, use polynomial identities to multiply each polynomial. Like I said, we're not going to do the identities. If this was a problem on the test, which you're not going to see an identities problem, but if you wanted to multiply that out, you don't have to use identities. 5x plus 8 squared. 5x plus 8 squared. That's the same thing as just 5x plus 8 times 5x plus 8. There's 2 of them. So I just multiply that out, just like I did up top. FOIL method, multiply that out, combine like terms, and I'm done. So I'm going to skip polynomial identities. I'm going to skip factor the polynomial because, again, this uses identities from that section. So I'm not going to do that. Pascal's triangle and the binomial theorem, same idea. I'm going to skip that. And then 22 also falls under 3.3, but I think 23, if it doesn't fall under 3.3, I can make it fall under 3.2. So the length of a rectangle is represented by this expression right there. And the width is represented by this expression here. What's the perimeter of the triangle? So let's kind of sketch out a picture of what we're talking about here. So we'll kind of draw out a triangle. They're saying the length is 3x cubed minus 2x squared plus 10x minus 4. And then the width is negative x cubed. So I'll write it over here. Negative x cubed plus 6x squared minus x plus 8. Okay. So length and width of a rectangle. We know the properties of a rectangle state that opposite sides are congruent to each other. So if this side is that length, this side has to also be that length. If this side is that length, then this side has to also be that length. Okay. What is the perimeter? Again, make sure you understand just the basic idea of those things. Area is just when you multiply length times width. Perimeter is when you add up all the sides. So this is just a lot of terms to keep track of, not a very difficult problem. But what I just said was the top and the bottom are the same length, the right and the left are the same length. So I'm just going to add all those like terms together. So I've got 2 of these. And then I've got 2 of these. And I want to see what that's going to equal. Okay, my perimeter. Did you have to write it out like this? No, you could have written this plus this plus this plus this. That just kind of seems like a lot of ink. So I'm just going to write it and just do the distribution method. Distribute that 2 through each of those sets of parentheses. So 2 times 3x cubed is 6x cubed. 2 times negative 2x squared is negative 4x squared. 2 times 10x is 20x. 2 times negative 4 is negative 8. And then now my next set of parentheses, 2 times negative x cubed is negative 2x cubed. 2 times 6x squared is 12x squared. 2 times negative x is negative 2x. 2 times 8 is 16. 16, there we go. And this is very similar to what we talked about before. I've got like terms here, so I want to add all my x cubes together. I want to add all my x squareds together. I'll add all my x's together. And then if I have any constants, which it looks like I do, I'll add them together. 6x cubed minus 2x cubed, that's 4x cubed. So I took care of those. I like to cross those out just so I know that I've taken care of them. Negative 4x squared plus 12x squared, so that's 8x squared. 20x minus 2x is 18x. And then negative 8 plus 16 is positive 8. So the answer to number 27, number 23, the answer is the perimeter is 4x cubed plus 8x squared plus 18x plus 8.